Hello and welcome. Look, if you're building on AWS, you already know that spinning up an API is just step one. The real challenge, making sure it's secure. That's exactly what we're going to tackle today. We're going to dive deep into the official AWS docs and build a super clear, layer-by-layer guide to locking down your API gateway. Let's jump right in.
So, let's start with a big fundamental question. You've just deployed your shiny new API on Amazon's absolutely massive global infrastructure. If something goes wrong, if there's a breach, who's on the hook for security? Is that an AWS problem, or is it your problem? Well, the answer is, it's a bit of both.
And to really unpack that, here's how we're going to do it. First, we'll cover the one concept you have to understand for all AWS security. Then, we're going to build up our defenses in 3 layers. First, protecting the data itself. Second, deciding who gets access. And finally, keeping an eye on everything. And we'll wrap it all up with a checklist you can actually use.
Okay, the core idea, the one that underpins everything, is this: the shared responsibility model. This isn't just some corporate jargon, it's the actual framework for how security works in the cloud. You really have to think of it like a partnership, a deal between you and AWS.
And this right here is how that pact breaks down. AWS handles the security of the cloud. That means the physical data centers, the cooling, the networking, the servers, all the heavy lifting infrastructure stuff. But, and this is the key, you are responsible for security in the cloud. That's your job. It means you have to configure your services correctly, you have to manage your data, you have to set up all the access controls. The best analogy is this: AWS gives you a super secure apartment building with guards, but you're still the one who has to lock your own apartment door.
So, with that foundation in place, let's build our first layer of defense: protecting the data. This is all about keeping your information safe, whether it's flying across the internet or just sitting in storage.
You know, it's really important to think about data in 2 different states. You've got data in transit. That's when information is actively moving, say from a user's phone to your API. And then you have data at rest. That's data that's just sitting there, maybe in a cache or a database. To truly secure your API, you have to protect both, because they face totally different kinds of threats.
So, how do we protect data while it's on the move? Well, API Gateway gives you a huge head start here. And this is a big deal. It only exposes HTTPS endpoints. That means all your traffic is encrypted by default. You literally can't create an unencrypted HTTP endpoint. This is a perfect example of AWS handling the security of the cloud by enforcing a really strong baseline for you.
And for data that's just sitting still, you've got some powerful tools for that too. You can, and you absolutely should, turn on encryption for any cached API responses. And behind the scenes, AWS is already using its Key Management Service, KMS, to encrypt really sensitive stuff, like the private keys for your custom domains. It's that kind of deeply integrated security that makes a difference.
Okay, now here is a critical warning straight from the documentation. This is so important. Never, ever put sensitive info like customer emails into tags or other free-form text fields. Why? Because that kind of data can show up in places you'd never expect, like in your billing reports or diagnostic logs. So the takeaway is clear. You have to treat your metadata with the exact same level of care as your actual data.
Okay, so our data is encrypted. Awesome. Now for layer 2. This is all about controlling who gets in, who can actually call your API, who has permission to change its settings. Basically, who gets the keys to the kingdom?
And the answer to that question is a service called AWS Identity and Access Management, or IAM for short. You can think of IAM as the central nervous system for all permissions across your entire AWS account. It's how you define exactly who can do what to which resources.
Now, IAM really boils down to 2 main ideas, 2 pillars. First, there's authentication. That's just proving you are who you say you are, kind of like showing your ID to a security guard. Then there's authorization. That's what you're actually allowed to do once you're inside. Can you open that door? Can you read that file? That part is all managed by things called policies. And these policies come in 2 main flavors. First, you have identity-based policies. You attach these to a person or a role, and it basically says, this person is allowed to do these specific things. Then you have resource-based policies. You attach these directly to the thing you want to protect, like your API, and it says, only these people are allowed to touch me. Mastering both is how you achieve something called least privilege. A really common mistake is to just grant wildcard permissions, which is like giving everyone a master key. A much better approach is to be super specific. This developer's role can only read data from this one specific API endpoint, and that's it. That's how you do least privilege right.
All right, we've encrypted our data, we've locked down access, but we are not done yet. For our third layer, we have to talk about visibility, because at the end of the day, you can't secure what you can't see.
And AWS gives you an amazing toolkit for this. Think of CloudWatch as your security guard in the watchtower, logging calls and setting off alarms if it sees something weird, like a sudden spike in errors. CloudTrail is more like your detective, writing down an audit log of every single change anyone makes. Then you've got X-Ray for tracing requests and finding bottlenecks, and AWS Config, which is kind of like your compliance officer. They're all super important, but let's zoom in on CloudTrail for a sec, because it's really the bedrock of any security investigation.
Yeah, out of all those tools, CloudTrail is special. It's not about real-time performance graphs. Its job is to create a permanent, unchangeable record of every single thing that happens in your account. This audit trail is your source of truth when things go wrong. So let's make this real and see exactly how it works.
It's actually a pretty simple but incredibly powerful process. Someone, could be a person, an application, whatever, makes a call to change your API gateway configuration. Instantly, CloudTrail logs that as an event. It captures everything: who did it, what they did, when they did it, and from where. Then that little event record gets securely sent to a place like an S3 bucket. If you ever have a security incident, this log is the first place you're going to look. It's your ground truth.
Whew, okay, we have covered a ton of ground, from the big picture responsibility model all the way down to the nitty-gritty of logging tools. So let's pull this all together into one final actionable checklist.
Here it is. These are the things you need to do. Number 1, always, always, always use least privilege with IAM. Number 2, log your API requests with CloudWatch. Number 3, set up alarms so you get notified automatically when something's wrong. 4, turn on CloudTrail from day 1. Don't wait. 5, use AWS Config to track changes so nothing gets changed without you knowing. And finally, use tools like AWS Security Hub to have AWS automatically check your work against all the best practices. This is your recipe for a secure API.
And that brings us to the end. If you follow these layers, you're going to have a really solid security posture. But security is never a set it and forget it kind of thing. So the question I want to leave you with is this. You built the API, but is its front door truly locked? And how are you going to make sure it stays locked day in and day out? Thanks for joining me.